Hello, class. I'm going to do a short Zoom video concerning the COREC number 3 titled Evaluating Square Roots. Okay. And this is something that was in the COREC workbook, these problems that were here. Let me write something down here. So evaluating square roots. So for the parts of a radical, this symbol here, this is not a long division symbol. This is called a radical symbol or a radical expression. And the number that sits underneath here is called a radicand. And oftentimes there's a number that sits here that's called the index, which is an imaginary 2 unless otherwise specified. So, and imaginary 2, not an imaginary 1, an imaginary 2, unless otherwise specified. Okay? And so all of these have an imaginary 2, all of these, and that's why they're called square roots. So an imaginary 2, so hence the square, hence the square root. Okay, because index is 2. Imaginary 2. Okay, so basically when you find the answer to this, what you're asking, because the index is 2, you're asking what number times itself, but just itself twice, just twice. That's where the 2 comes in. What number times itself, but how many times? How many times over and over? Just twice. What number times itself twice gives us back the radicand, which in this case is 25. So remember, this is called a radicand. Okay, so the radicand is 25, and then the index is imaginary 2. So that's where times itself twice comes in, because the index is imaginary 2, and then the radicand is 25, the number underneath the radical expression. Okay, so in our case, the answer would be 5, and that's because 5 times 5 is 25. Okay, and we don't say, sometimes when students are learning this, they do this, but this is not right. Don't say the answer is square root of 5. That is not correct. That is wrong. The answer is not the square root of 5. The answer is just 5. The square root of 25 is equal to 5. And why? That's because 5 times 5, a number times itself twice here, is 25. Okay, but don't say the answer is square root of 5. Okay, now on the calculator, to show you the calculator commands, there's the second button here, the second button, and there's this square root key. You see that square root key? It's in blue. That's why we use the second button, because that's in blue. And you hit this x squared key. So I'm gonna say on the TI 84, what you would press is you would press the second button, and then you would press the x squared button, because right on top of that you have the square root, and then you would type the radicand, which is 25, and then you would press the enter, which is like the equal sign. Okay, so those should be the steps to find that. So let's see. So you would press the second button, and then you would press this x squared button because it's got the radical. Okay, see that? And then you press the radicand, which is 25, and then you press the enter button, which is right here, and it does give you 5. See that? Okay. And then the other thing I can show you is, like, I happen to have a multiplication chart here. Let me make this smaller here. And it turns out there's also patterns, like on the multiplication table. It says here that green denotes perfect squares. So can you see this, like this green diagonal here? These are all perfect squares. So like a while ago, we were doing this. The square root of 25 is 5. So you see if I go across this way, that's a 5 there, and that's a 5 there. So if I make it larger, see how that 25 is on the diagonal? That green denotes perfect squares. So I go across this way, it's 5. Go up here, it's 5. Okay. And if I were to say, what's the square root of 441, then I just go back. See, 21. Or I can go upwards. See, 21. So that says, that would say that, and I don't think I see that on here, and it's not one of these, but if I were to say the square root of 441, that would equal 21. And the reason is because 21 times 21 equals 441. Okay, so if I use my calculator, I press the second button and then this x squared, because that's got the blue radical. And then I press the radicand 441, and then I hit the enter button right here, enter, and see it gives me 21. Okay, and that's because 21 times 21 gives me back 441. Okay, so those are these are evaluating square roots. Okay. So the square root of 36, again, what number times itself gives back that radicand 36? So it would be 6. Yeah, because 6 times 6 is 36. Okay. And so the answer is 6. This is what the computer will want for scratch work. I mean, for answers, this is what the computer wants for answers. So again, if I use my calculator, second, and then square root 36, and then press the enter button, and it gives me 6. Okay. All right. Square root of 1 is 1. And that's because 1 times 1 is 1. Okay. So second square root 1, and then press enter, is 1. See that? Okay. Okay. And then square root of 121. Okay, so I can also use my little chart here. Square root of 121 is right here. So I go across, see, that's 11. Even if I go upwards here, that's 11. Okay, so square root of 121 is 11. And the reason is that's because 11 times 11 is 121. Okay, so if I show that in a calculator, second, and then square root, and then 121, and then enter, that's 11. Okay. All right. So on your COREC, that's what you'll have is this is evaluating square roots, and that's what that means. What number times itself, like twice, gives you back that radicand. Okay. Now I know you don't have in your homework, you don't connect math for COREC. I know you don't have cube roots, but I could show you one more just so you get the feel for these roots in case you have to take an intermediate algebra class. But suppose you had cube root of 8. So this is still called a radicand, and this is still called an index. But now the index is not, it's not imaginary 2, it's specified. It's specified 3. And when you find the cube root of 8, you're basically asking yourself, what number times itself, so repetitively over and over, what number times itself but thrice, repetitively over and over, over and over, but how many times? 3 times. What number times itself but thrice, gives us back the radicand 8. Okay. And so for us, that answer would be 2, because 2 times 2 times 2, that gives us, that equals 8. 2 times 2 is 4, and then 4 times 2, it does give us back 8. So 2 times 2 times 2. What number times itself repetitively over and over, but 3 times gives us back this radicand, which is 8. So it's going to be 2. Is that all right then? Okay. So you don't have any cube roots on the homework, but let's see, on the calculator, I don't think this one has a cube root. Some of them have the cube roots on it, but I think on this one, let me see. I haven't done a cube root in a while. Let's see, where would that be? I don't see a cube root. Let's see. Where's the generic root? That's the square root. I think that would be under the math. Let me check out the math button. Math. You're not going to have any on your homework, but there, yeah, there's the cube root there. Cube root. And then this is like if you had a 4th root, a 5th root, a 6th root, there's the cube root there. So let's see, that's number 4. Okay, so let's try that. Let's hit 4. Okay, see that pops up? See that? So on the calculator, on the TI-84, and of course this is the plus, you would press math. And let me go back and do that again. I pressed math. Let me clear that. I hit math, and then I just press 4. And I press 4 because you want this one for cube root of, and then it has like a parenthesis like that. Yeah. So I hit math. Clear that. Hit math. And then I hit number 4 because of this. So I just hit 4 and then that pops up. And then I type the radicand, which was 8, right? And the number underneath the radical expression. So I type 8 and then I just press the enter button. And it should give me 2. Okay. So yeah, so a cube root means what number times itself repetitively over and over, but 3 times, 2 times 2 times 2 gives you back 8. That's what the index does. And then I'll show you one more. You're not going to have any of these, but I just show you like a fourth root of something. Fourth root, let me think of one. Let's see. Okay, let me do fourth root of 1,296. Okay, so this is called the radicand. This is called the index. And so you're asking yourself, what number times itself repetitively but over and over repetitively, but 4 times gives us back 1,296, which is the radicand. Okay. Okay. So then if I type this in, I have to type in that index 4 first, and I would have to do 4 because the index is 4. So I have to type in 4, and then I go back to math, and then I would go to number 5. See number 5? Because 5 has a generic X index, and I'm telling it that I want it for the index to be 4. So if you've got an index that's 4 or greater, then you would go this route. So you identify the index, I press 4, then I would press 5 because I want that generic X index, and see how that fixes it. See that X now turns into a 4, and then I would type 1296, the radicand, and then hit enter. And it turns out that the answer is 6. And the reason why it's 6 is because if I check my work, it's because 6 times 6 times 6 times 6. So 1, 2, 3, 4. 1, 2, 3, 4. 6 times 6 times 6 times 6 gives me 1,296. Okay. Okay. So this is 6 because 6 times 6 times 6 times 6 equals 1,296. So that's how this plays a part. The index plays a part. And this means what number times itself, repeated over and over, but 4 times, 1, 2, 3, 4 times, okay, gives us 1,296, okay? So here, if I put the calculator commands, TI 84, it would say that you'd have to type the index, which here is 4, and then you'd have to press math, and then you'd have to press, was it number 5? So type the index 4, press the math, yep, and then you'd have to press 5 because you want 5 and then this generic X here, which will turn that to a 4 when you type that. Okay, and then you're going to type the radicand, which is 1,296. Yep. And then you press the enter button. and then it would show you that it was 6. Yeah, so that's what we did. That's what we did. Okie doke. Okay, so that was just a little bit extra. So you're going to just have square roots, and so I showed you that initially, but I just wanted to give you that feel for a cube root and a fourth root when they're the roots, the indexes can be larger. Okay, all right. So that's my video for this co-rec on evaluating square roots then, okay? And we just did a few extra. We did a cube root and we did a fourth root, but your homework is going to just be covering evaluating square roots, okay? All right. Take care.